Have you always wanted to test CODESYS Virtual Control SL or CODESYS Virtual Safe Control SL, but don't have the hardware or time to set everything up for testing? No problem. You can test our Virtual PLC portfolio directly on your Windows PC. No additional hardware required. In this video, we show you how to set up CODESYS Virtual Control on your PC using the Windows tool Hyper-V. If you're using WSL2 instead, we've got a separate video just for that. We'll start with an overview of both solutions, discussing the respective strengths, limitations, and useful areas of application. Then we will walk you step by step through the setup process for a Docker-based virtual PLC environment. All command line commands can be found in the video description. Due to time constraints, this video only demonstrates CODESYS Virtual Control. However, the use of Virtual Safe Control is also possible. More detailed information can be found in our online help in the Safe House scenario. The link to this entry can be found in the video description. First up is an overview of the two solutions and their differences. Hyper-V, Microsoft's integrated hypervisor, enables running complete Linux or Windows VMs with their own kernel. This allows you to install your own preempt RT kernels, industrial Ethernet drivers, and other specialized software required for more complex control field bus applications. An external vSwitch, VLAN tagging, and, if needed, SR-IOV provide near-native hardware access and allow you to pass broadcast and multicast frames to the VM. Hyper-V offers enterprise features such as snapshots, live migration, shielded VMs, and failover clustering. CPU and resource pinning, along with new jitter counters, for example in Windows Server 2025, enable targeted optimization for tough cycle times. Disadvantages: Hyper-V requires more resources because a separate operating system is started for each VM. This means that startup times are longer and both RAM and hard disk requirements increase. In addition, Hyper-V is only available on Windows Pro, Enterprise or Server. Compared to WSL2, GUI integration is less convenient, and remote tools such as SSH, FTP, RDP or VNC are required to access the VM. Hyper-V is recommended if you want to run hardware-in-the-loop fieldbus protocols with real-time requirements, multiple virtual controllers, cluster environments, or productive edge servers with enhanced security and availability requirements. WSL2 enables Linux environments to run directly and seamlessly on a Windows computer. It starts within seconds and is deeply integrated into Windows, for example via the network share //WSL$ and shared clipboard. Thanks to WSLG, Linux applications with a graphical user interface can be displayed directly in Windows. A key advantage of using Virtual Control is that the setup of WSL is much faster than Hyper-V. In addition, WSL2 is more resource efficient because Docker runs directly in WSL kernel without a separate hypervisor. This allows Virtual Control to run as a Docker container without significant overhead. Through memory management with automatic memory reclaim, WSL2 returns unused memory to the Windows system, which keeps resource usage efficient. Unlike Hyper-V, WSL2 also runs on Windows Home. However, there are certain limitations. In particular, layer 2 access is not possible. This means that industrial field buses such as EtherCAT or Profinet IRT, which require raw sockets or special drivers, cannot be executed. Networking in WSL2 is done via NAT, mirrored, or virtual proxy, all of which provide only limited access to the network layer. Hard real-time is also not supported. USB or PCI pass-through and Wi-Fi bridging are available only experimentally through a workaround, with a VM and the hypervisor typically being the better and simpler solution. The preempt RT kernel is also not available in WSL2. To be more precise, the RT function is disabled. While it can be enabled, it is then only available as soft real-time. WSL2 is ideal for development and simulation tasks, OPC UA or MQTT communication, and Modbus TCP applications without a connection to the field level. It is also well suited for initial demos without real I/O hardware or for the use on less powerful laptops. If WSL2 is the right tool for you, you can jump to the WSL video via the link in the video description. Now let's walk through setting up a virtual machine under Hyper-V for use with CODESYS Virtual Control. For that purpose, first turn Windows features on and off and enable the box next to Hyper-V and restart your PC. Start the Hyper-V manager and create a new virtual machine. It is recommended to select Ubuntu as the operating system image. Although Ubuntu is not officially supported, it works well in practice. If you want to stay as close as possible to the future production system, you may prefer to download and integrate a Debian image. However, Ubuntu is perfectly suitable for testing and experimenting. Follow the installation wizard until the system is installed. Once the installation is complete, shut down the VM. Reopen the Hyper-V manager as an administrator to continue with the next steps. Next, configure the network settings for the Ethernet connection for the field bus. If you don't need this functionality right away, you can skip this step and come back to it later on. Create an external vSwitch that is connected to your physical Ethernet adapter. Uncheck the box next to Allow Management Operating System to share this network adapter. Please note that this means that the physical adapter is exclusively available for the VM and no longer available for Windows. Start the VM and connect to the console. Perform a systems update. Install the necessary dependencies for Virtual Control and Docker. For Ubuntu, use the following commands. For Debian, a modified command applies as listed in the documentation. Edit the following file. And make sure that the line permit root login yes is committed. Activate the SSH server and display the IP address of the Ethernet adapter, for example with the first Ethernet address is the relevant IP for the deploy tool. Now open the deploy tool via the Tools menu and select the Communication tab. Connect on your target device via SSH using the IP address. Once connected, an overview of the device data will be displayed under Device Information. If necessary, you can restart the operating system on the device using the Reboot button. Installed Linux packages can be managed via the Package Management button, allowing you to uninstall or install packages by selection. To install packages, download the corresponding dep or RPM files and install them on the host system using Package Management. Currently, Debian and Red Hat Enterprise Linux are supported. In the Deployment tab, you can install packages and images on the desired platform. An overview of the packages already installed on the device is also available. Installed images for the virtualization environment are clearly displayed. Now install the components you need. In our case, these include the images for Virtual Control, Virtual Edge Gateway, and CODESYS License Server. The tool automatically suggests only those products that are supported by the target device, preventing compatibility issues that may be due to the CPU architecture, for example. Once the installation is completed, we can immediately start using the runtime. In the Operation tab, you will find all installed services, such as the license server, along with their status. You can load and view the CODESYS log. Use the OpenWBM action to open the license server web interface. After logging in with your SSH access data, you can manage your licenses in the CODESYS WBM tab. The license server is required for licensing CODESYS Virtual Control. Here, you store your licenses, which are then automatically retrieved by the virtual controls. The license server can either run on the same device as the runtime instances or on any other device within the network. Create a new instance of Virtual Control and Virtual Edge Gateway in the vPLC area. On the right-hand side, in the Settings area, configure the instances according to your requirements and needs of the individual containers. For example, set the instance to auto-start and define dependencies. In our case, vPLC1 is dependent on vEdge, as otherwise no connection to the virtual controller can be established. Ensure that the IP address of the network license server is configured, as CODESYS virtual controllers can only be operated with network licenses. Under Network, assign the instance to a specific container network. To use Industrial Ethernet, the instance requires access to an Ethernet adapter, which can be mapped in the NIC field. If you are using web visualization, open the corresponding port of the instance. In our example, this is port 8080. Make sure that the settings are saved correctly. Finally, to allow vEdge to locate the vPLC1 instance later, it must also be assigned to the corresponding container network. The Deploy tool allows you to easily duplicate instances. In this example, we are duplicating the instance vPLC1. To avoid conflicts with the source instance, always review and adjust the settings accordingly. You can also export your instance configuration as a file. The description of the instance is stored in a CFG file in the zip file. Now start your instance. You will notice that vPLC1 also starts vEdge, on which vPLC1 depends. Once the status of the instances has changed to running, you can connect to vPLC1 with the vEdge gateway. For this video, we have already prepared the vEdge gateway and the CODESYS development system. After creating the user, you can log into vPLC1, download the application to the controller and start it. Using the IP address previously used in the Deploy tool, we can now access the web visualization via port 8080. When an instance is no longer needed, it can simply be stopped and deleted to maintain a tidy overview and save resources. If necessary, you can also re-import the deleted and previously exported instances. After restarting your PC, you can as well restart the Hyper-V virtual machine. The containers in AutoStart are then accessible again within seconds. Thank you for watching this video.